Every time you flip a switch, you're tapping into one of the most incredible and complex machines ever built, the power grid. But what keeps that whole thing from falling apart? Well, today, we're going to pull back the curtain on the grid's ultimate safety switch. Just look at these things. They're absolute giants. And no, they're not just some random part of a substation. These are high-voltage circuit breakers. Think of them as the ultimate protectors of the entire power network. They are the first and last line of defense. So that brings up a pretty scary question, right? If something goes wrong, say lightning hits a power line, what stops that one little problem from cascading into a massive coast-to-coast blackout? The answer is these guys right here. They're designed to snuff out a problem in the blink of an eye. And that's why Guardians of the Grid is the perfect name for them. They really are the unsung heroes working behind the scenes, making sure our electricity supply is stable and reliable every single second of every single day. Their job is so much bigger than just keeping your lights on. It's about protecting multi-million-dollar transformers from blowing up. To do that, they have to stop these enormous fault currents in just a few milliseconds. We're talking literally faster than you can blink. And here is the craziest part of their job. Unlike a light switch in your house, these breakers might do absolutely nothing for months or even years at a time. But the moment a fault happens, they have to work perfectly, instantly. There are absolutely no do-overs. Okay, so how on earth do you stop that much energy that fast? To get that, we need to dive into the one massive physics problem every single circuit breaker has to solve. It's called the electric arc. So when the contacts inside a breaker pull apart to stop the current, the electricity really doesn't want to stop. It literally jumps across the gap, creating this intensely powerful electric arc. The best way to think about it, it's like trying to tame a bolt of lightning inside a tiny metal box. It's unbelievably hot, it's destructive, and you have to put it out. So engineers have come up with some really clever ways to quench that arc. Some breakers use a special gas called SF6, which is an amazing insulator. Others create a near-perfect vacuum inside, where an arc just can't form. And older designs, they literally used powerful blasts of air or jets of oil to smother the arc. But here's the thing. These Guardians aren't invincible. They're complex machines, and sometimes they fail. Understanding why they fail is the absolute key to preventing it. Now check this out. This chart is based on decades of data from grids all over the world, and it shows the top reasons these breakers fail. And just look at that number one cause, fails to perform requested operation. What does that mean? It means when the grid needed it most, the breaker just got stuck. It didn't open or close. And this is the stat that blows my mind. You'd think it's an electrical problem, right? Some fancy component burned out? Nope. The data shows that around 70% of major failures are purely mechanical. It's not the electricity, it's the nuts and bolts. This quote from one of the studies really gets to the heart of the problem. Because these things just sit there for so long, the constant weight and pressure on the metal parts can literally squeeze all the grease out of the bearings. It's kind of like a firefighter's emergency valve that hasn't been turned in 20 years. When you finally need it, it might be rusted shut. So, if the biggest enemy is just sitting still, what do? I mean, you can't just operate them for fun. The solution is a really sophisticated testing strategy. Basically, you give these massive machines a regular high-voltage health check. The way we do maintenance has gotten so much smarter over the years. We started with the wait for it to break method, which is obviously a terrible idea. Then we moved to a preventative schedule, just guessing what it might fail. But today, the gold standard is condition-based maintenance. We use advanced tests to know the exact health of the breaker and predict failures before they can ever happen. So what's in this checkup? Oh, it's the whole shebang. Technicians measure contact timing down to the microsecond. They analyze the motion, the speed, the travel of all the internal parts. They even analyze the vibration signature when it operates, which is a lot like a doctor listening to your heartbeat to find hidden problems. Now, doing all this detailed testing is absolutely critical, but it comes with its own challenges. And the number one priority has to be making this vital work not just smarter, but a whole lot safer for the people out there on the front lines. And this right here is a perfect example of a huge leap forward in safety. For years, to do these tests, a technician had to physically remove a safety ground wire. which, as you can imagine, is a pretty nerve-wracking thing to do in a high-voltage yard. But new methods, like this dual-ground technology, let them do all the testing while the breaker stays safely grounded on both sides. It's a true game-changer for worker safety. And this really shows you the modern reality of grid maintenance. On the left, you've got this massive piece of machinery. On the right, you've got this sophisticated, almost surgical diagnostic tool you need to understand what's going on inside. It's this marriage of powerful hardware and intelligent testing that keeps our power flowing. At the end of the day, all this testing, all this technology, it's all about one thing. It's about finding that sweet spot, getting the absolute maximum reliability so the lights stay on, while doing it at the lowest possible cost over the life of the equipment. All right, so what are the big takeaways here? First, high-voltage circuit breakers are the silent guardians of our grid. Second, their biggest enemy isn't some crazy electrical surge. It's often just simple mechanical failure from sitting still too long. Third, modern testing is a data-driven health check to stop those failures before they happen. And finally, new innovations are making this incredibly important job safer than it's ever been. So the next time you flip a light switch, just for a second, think about this. Somewhere out there, a massive, silent guardian has been standing ready, perfectly maintained, maybe for years, just waiting for that 1,000th of a second when it's needed to keep your world lit.